Hi there, this is Professor Eckhouse, and I'm going to talk today about section 2.1, solving inequalities, where we're going to learn about three different kinds of ways to represent an inequality with inequality notations, kind of the old-fashioned way, a number line, just so you can visualize it, and interval notation, which is a more modern way of representing inequalities. And then we're going to look at solving one-step and multi-step inequalities. So I really don't want to read all of these to you. I think that's boring so for you and me. So pause the video and read them. Make sure you understand how to read each one of these and what they mean. Okay, so there are three ways to represent inequalities. Like I said, inequality notation, a graph, which is a number line, and interval notation. And I am going to show you all three of those today on this little table that I've made. Okay, so inequality notation, I'm going to say all of these, pause the video if you need to so you can write these things down so that you understand it. I'm going to use some colors so we can see what's what here. But I'm going to say x is greater than a. And so if a was here, then x is everything greater, but it's not or equal to, so I put an open circle on a. Okay, so an open circle on a. That means x is greater than a. All right, so now the way we say this in interval notation is we say that this goes from a to infinity, okay? And it does not include a, so we put a round bracket, a parenthesis, and it does not include infinity because we never get to infinity. Okay, infinity never actually is a place that we arrive at. So we don't get there, we never touch it, so it is a curved bracket. So curved means does not include, and square brackets means it does include. Okay, and they can be different on either side, and we'll look at some like that. Okay, so x is less than a. X is less than a, so if a were here, it does not include a, and it's everything less than, all the way down to negative infinity. Okay, so positive infinity is over here, we just write infinity, but negative infinity is in the other direction. So we're going to say that x could be anything from negative infinity up to a, not including either one. All right, so let's look at the next one. I'm going to do it in a different color because this is a little different. X is greater than or equal to a. So we're going to put a solid dot, and we're going to say it's greater than, so it goes over to the right. Okay, so it does include a. So here's how we do this one. We say it goes from a to, right, this is infinity, up to infinity. It never includes infinity, but it does include a, and that's a square bracket. All right, so x is less than or equal to a, so here's a. We're going to include it, and we're going to go to the left, okay, to the left, that way. All right, so how would we write that? Pause the video and see if you can try it. All right, so it's going to go from negative infinity up to a. Negative infinity is never included. A in this case is. All right, so let's look at a little bit different kind of problem here, and that is when x is between a and b. So we have a and b. Okay, so those are our two numbers, and x is between them, but it doesn't include them. So open circle, and everything in between. So we're going to say that x can go from a to b, and it does not include either one. And I know it's weird, it looks like it's a point, so we have to say on the interval. Okay, so it has to be clear that this is not a point. It's on the interval from a to b. That's how we say it, on the interval. Okay, next one, we are going from a to b again, except this time it does include a, because it says or equal to, but it does not include b. So again, it's in between, and we would write it from a to b, not including b, but we do include a. All right, the next one, we go from a to b. It does not include a, it does include b, so, and everything in between. So we say it goes from a to b, It does include B. It does not include A. And the last one like that is, hopefully you can pause and try this one. But it does include A and B and everything in between. So we would say from A, on the interval from A to B, including A and B. All right, this one is going to go from x is less than A, so here's A, and greater than B, or greater than B. So it's going to be less than A, open circle, because it's not or equal to, and greater than B, but not or equal to. Now it could be or equal to and have a closed circle, and I didn't include that one because this is just it's a lot of information. It's kind of very repetitive. Okay, so in this case, we are going to say that these two are union with each other, but there is nothing in the middle. Okay, so these two are union with each other, and we use the letter U. So we're going to say it goes from negative infinity up to A. It does not include either one. Union with, going from B up to infinity. And the best way to do this is to start on the left and say, where am I? Well, I'm at negative infinity. Right now I'm going up, 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 up to A, but I'm not including A. So I'm going to write that as one thing. And then the union with in the middle. And now I've got another thing from B to infinity, to positive infinity. Okay, so that's how you would write that, as I did over on the right. All real numbers. That's all of it, right? All of it, everything, the whole thing. And we would write that as, in interval notation, we would say negative infinity to positive infinity with curved brackets because it never gets to infinity. Okay, so that's your lesson on all of it. So you might need to come back and see this again because it does take a little while to get used to interval notation. All right, so multiplication and division properties of inequalities. I want to just make sure you understand, if you multiply both sides, it's just like equalities. Okay, it's just like when you have an equation. So just like equations. Equations that have equal signs. So if I multiply both sides by, say, we're going to multiply by 2. Okay, I would say the final inequality then is going to be 5 times 2 is 10, is greater than 3 times 2 is 6. Okay, multiply both sides by 2, right? So I've gone this times 2 and this times 2, just like if it was an equality. Right, what if I did it with letters? What if I multiplied by C on both sides? So my final equality would be AC is greater than BC. So I just multiplied both sides by C. All right, what if it was negative? What if it was negative? All right, so let's try that. I'm going to say negative 2. Okay, so I'm going to multiply this side times negative 2 and this side times negative 2, both sides. Okay, and I'm going to get negative 10 is greater than negative 6. Think about the number line. We've got our number line here. Negative 10 is here, negative 6 is here. Is negative 10 really greater than negative 6? No, it is not. So what are we going to do? We're going to have to switch the sign. So we're going to have to, when we multiply by a negative, we have to switch the sign. So switch sign, because when you multiply by a negative, it makes everything backwards. Okay, it's opposite. It creates opposites. So negative 10 is less than negative 6. So it's just like equations when it's positive. But when it's negative, when you multiply by a negative, you've got to switch the signs. Okay, so if I multiplied by negative C, I would say that negative AC is less than negative BC. Okay, so I switched this sign to be less than. So the same is going to be true for division. So let's just say I divide both sides down here by 2. I get 4 over 2 is greater than 2 over 2. I just divided both sides. That is going to become 2 is greater than 1. Is that true? Yes, that's true. Okay, let's check if we divided just by a c, say, we would have a over c is greater than b over c. Okay, so any number that you divide by, that is going to be true if it's positive. All right, so now let's say I'm going to do it by negative 2. So I get 4 over negative 2 is greater than 2 over negative 2. So that becomes negative 2 is greater than negative 1, and that is not true. No, that is not true. So I have to switch the sign. Okay, so switch the sign. Okay, so you're going to get, in this case again, negative 2 is less than negative 1. Switch the sign. Okay, so when we do this with just, a negative c, let's make it negative c. So if we've got a over negative c, we're going to have to switch this sign right here to become, instead of greater than, it's going to become less than b over negative c. Okay, so make sure you switch that sign. All right, so now we're going to solve inequalities using the addition property. Addition and subtraction within inequalities work exactly the same. Up here, it only works the same with multiplication and division when it's positive. Okay, only when it's positive. All right, so let's take a look at this first one. We're going to do it all 3 ways. We're going to do it with inequality notation, interval notation, and the number line. And the number line will make it easier. Okay, so just like this, there was an equality sign right here. What would we do to solve for x? Well, we would say divided by 3, and I get x is less than 6 divided by 3 is 2. So x is less than 2 is one way to say it. So that's the first way. Here's the other way on the picture. 2 is less than, so I have to do an open circle, and I'm going to go to the left. Okay, so how would we do this? Well, this goes to negative infinity. Writing interval notation, I'm going from negative infinity, I never include negative infinity, up to 2. It's an open circle, so I use that. So there's interval notation. All right, next one. So I've got 2x is greater than or equal to negative 4. So we're going to divide both sides by 2. Now there's a negative there, but I'm not dividing by a negative, so I don't switch the sign. X is greater than or equal to negative 4 over 2 is negative 2. Okay, so that's one way to say it. We've got, I'm going to put negative 2 right here. Nice thing about a blank number line is you can just stick your number in there anywhere you want. So it does include it because it's greater than or equal to, and it goes to the right from there up to infinity. So what is this interval notation going to look like? It goes from negative 2 up to infinity. Now, does it include the negative 2? Yes, it does. Does it include infinity? Never. Okay, so that's the third way. All right, you try number 3. All right, so in this one, it's just plus and minus. So we're going to plus add 25. And I'm going to get that x is less than 37. Okay, so I'm just going to go over here and put 37 on here. It's less than, not equal to, so use an open circle and go that way down to negative infinity. So our interval notation goes from negative infinity up to 37. It does not include negative infinity. It does not include 37. Okay, so that's the third way. 3 ways to show it. And I would do it in that order because the picture, it really helps to come up with this. All right, next one. We're going to subtract 9 from both sides. And I get x is greater than or equal to negative 3. I don't switch the sign because I didn't multiply or divide by negative. All right, so that's one way to represent this. Then we've got negative 3 greater than or equal to. So put a solid dot and then to the right because it's greater than. All right, so this goes up to infinity from negative 3. So from negative 3 up to infinity. Does it include negative 3? Yes. And infinity, never. Okay. So you would say this, the interval from negative 3 to infinity is where x can lie. That's what x equals. All right, I think I've got just a couple more here. Yeah, 2 more. All right, try this one. See what you can do with it. All right, so we're going to do this exactly the same as we would do an equation. And if we can multiply or divide by a negative, then we will deal with the sign. All right, so I'm going to subtract 10x from both sides because these, we do like to get the x's on the left because that's the way we read it. Okay, so you want the variable on the left for these. So get variable, get x to the left. Otherwise, some people can do it, it's fine if you leave it on the right and can switch it at the end to make sure it makes sense to you. But when we read it, we read inequalities left to right. So I've got 13. Negative 7 minus 10 is negative 17x is greater than negative 4. Right now I'm going to subtract 13 from both sides. And I get negative 17x, I forgot the equal sign, is greater than or equal to negative 17. All right, now I need to divide both sides by negative 17. So what do I need to do? Give myself a little more space while you think. I am going to have to switch the sign right here. Okay, so it becomes less than or equal to. Okay, so this becomes less than or equal to. Make sure you do that when you divide it by, it's because of this negative right here, right? That causes that to switch. All right, so we get x is less than or equal to negative 17 divided by negative 17 is 1. All right, so x, I've got a 1 right here. Less than or equal to means it's going to be solid. I'm going to go to the left. Okay, so negative infinity is where we go to. So our interval is going to be negative infinity up to 1. It does not include negative infinity. It does include 1. Okay, so two different ways to write the equation, and the other is the picture. Okay, so 3 ways once again. All right, last one. What would you do with this one? And I would say clear the fractions. Definitely clear the fractions first. Okay, so I'm going to look for the least common multiple of 4, 8, and 3. Okay, so the least common multiple of 4, 8, and 3 is going to be 24. There's a very loud blue jay outside my window. All right, so I'm going to multiply. Let's see, do I want to rewrite this? I think I will. I think I'm going to rewrite this. I've got lots of room. So negative 3/4 x is greater than or equal to, I'm going to leave some space, negative 5/8 plus, I'll leave some space again, 2/3 x. All right, so I want to multiply every single thing by 24. Not 1 over 24, just 24. Okay, so every single thing gets multiplied. And you can say 24 over 1 if that helps you to keep track of where things go. I'm going to multiply by 24 over 1. 24 over 1. So I'm distributing it to every single thing. All right, so in this case, I'm going to get 6 right there. Right? I get 6 times negative 3. So that is going to become negative 18x is greater than or equal to, all right, this next one, 24 divided by 8 is going to be 3 over 1. So 3 times negative 5 is negative 15 plus 24 divided by 3 is 8. And all of those should go away. If they don't go away, you did not find the right least common multiple. All right, so 8 times 2 is 16x. All right, so I'm going to subtract 16x from both sides, and I get negative 34x is greater than or equal to negative 15. All right, now I'm going to have to divide both sides by negative 34. So I'll do this in red so it's really obvious. Negative 34, negative 34. So that means this is going to switch to less than or equal to. Okay, so I get x is less than or equal to negative 15 over negative 34 is 15/34. Now that doesn't reduce at all, so I'm just going to come up here and I'm going to write 15/34. Okay, and where does it go from there? Well, it's going to be less than or equal to. So solid dot to the left to negative infinity. Okay, so interval notation is going to look like this: negative infinity to 15/34. Don't even worry about it, just leave it like that. All right, it never includes negative infinity. In this case, it does include the number. Okay, so it's because it's or equal to. Okay, so those are three ways of showing the answer. All right, thanks for watching.